In the last part of this course, we are going to turn our 2D trusses into a space truss structure. But before jumping into our Grasshopper definition, we have to explain a bit what tree structures or data trees are. So, tree structure is basically a list of lists. And to explain this concept a bit better, I'm going to use the points of our upper chords, these ones here. So, let me save these points into a point parameter, like that. So basically, there are three data structures in Grasshopper. We have items, we have lists, and we have trees. And we already saw items and lists in the other parts of this course, and now let's explain what data trees or tree structures are. So we can notice that this is a tree structure. What we have here instead of this parameter, first, because of the wire, as we said before, now it has turned into a dashed line, which implies that we are plugging a tree into this parameter here. But also, we can get a panel in Grasshopper, and if we connect the output of this parameter here, we can see that we don't have a single list here, but actually a list of lists. And by the way, it's one of these lists that we have inside of this tree structure. We call them branches because we make this analogy with trees. And also we can leave our mouse here and we can see that we have actually 6 branches and each of them has 9 items. And also we can get this component here. It is the param viewer, and we can connect it to this data tree, and now we can see properly what makes up this data tree, in this case these branches, and each branch has a path associated to it. So the first branch would have the path 0, 0, then the next one 0, 1, and so on. So when we are dealing with data trees, we have paths instead of indexes. And if we make right click into this component, the parameter viewer, we can choose to draw the data tree actually. So now we can see that we have our branches here, and these are the items that belong to each branch. And to illustrate this concept even better, let me get our favorite component of Grasshopper, which is of course the point list component. So now, if we connect our point list with our data tree with our point data tree here, we can of course specify a size of 0.5. And now let's get back to Rhino. So we can see that we have our 6 branches here, and these are the items of each branch, which I think is a very visual approach to understanding data trees. And let me just hide our elements of our trusses because we don't need them for this explanation. Okay, better. So this, as we said, these are basically our branches and the items on each branch. Let me explain a bit some concepts now, because we already see that when we do right click into an output parameter, we have different options here. So of course, the first one is reverse, which is very easy because we are just going to reverse the order of the items of each list, as you see in the Rhino viewport. Now, we have the next option, which is flatten. Okay, so if we flatten a data tree, what we are going to do is to remove our tree structure, let's say, so that we have just now a list of items. So we have just now all items belong to the same branch, the only branch, which is basically a single list. So let's undo this like that. Now we have our data tree from before, and finally we have this graphed option, which actually is completely the opposite from flattening. So when we graph a tree, what we do is that we store its item into a singular branch. So now you can see that we have more branches here, and each branch has just one item, as you can see, for instance, even in Rhino or here. So we have now several branches. You can see that there is an additional index in our branch paths, and anyway, each branch has just one item. And finally, let's undo this. We have the simplify option, because now you can see that every branch has a path which is made up of 2 indexes, and the first index is always 0. So what we can do is, okay, I don't want to be dealing with this additional index because perhaps it can create errors later on if we use this path to select branches and so on, as we are going to see. So what we can do is to simplify our tree. So if we do that, we are going to see that the output remains the same, but now if we take a look at the path of our branches, they are just made up of 1 index. I mean, the index that provides some kind of a meaning to this path definition. Okay, so now this is some introductory explanation to trees, and now let's see how we can manipulate data trees or tree structures. So first, let's imagine that we want to select a certain item from a tree, and for that we could use again the list item component. But this is very interesting because if you remember, when we use this component with a list, we could get a single item from this list. But now, if we use this component with a data tree, what is happening? And let me turn off this point list for 1 second. So now what is happening is that we are selecting the point with index 5, but in its branch or its list at the same time. So this is basically how tree structures in Grasshopper work. When we plug them into a component or a group of components, then the action of that component is performed in its list that makes up the tree structure. And this is very powerful. Actually, if you think about it, that's the reason that explains why our original definition of truss structures is working when we change from having just 1 baseline to different baselines. So now, as you can see, we have several baselines here, and then this turned into a data tree, but still the definition works because Grasshopper is connecting the points with the same index. If you remember, the point with index 0 with the point of index 0 and so on and so on. Grasshopper is doing that in all branches at the same time. So that is something very, very powerful to keep in mind when dealing with tree structures. Okay, so that's basically how we can select a single item from its list or from its branch, but also there is a possibility of selecting a single branch of the tree, so the complete list. And we are going to see that right now. So we have to come to this, of course, sets category, and then under this tree panel, we can select, for instance, tree branch. So now in tree branch, we have to provide, of course, our tree structure, and also we have to specify a path. So in this case, what we have to do, for instance, let's select the path with indexes 0, 1. We would have to use a Grasshopper panel, like that, and then we have to write, of course, inside of curly brackets, 0, semicolon 1, like that. And now we can see that, we are getting the branch which has this particular index. We have written this manually into this Grasshopper panel, so this is not very parametric, because if we change the input parameters of a certain Grasshopper definition, there are a lot of possibilities that this method doesn't work anymore. So actually there is another approach to get a certain path from a tree, which is actually to use this parameter viewer, because if you get a panel here, actually the output of this Grasshopper component is no other thing than the paths that define the branches of our tree. So what we can do is to get the list item component and just provide this list of paths as input, and then we can now select different paths this way with the list item component very easily, very intuitively, and now we can connect it with our tree branch component, and we can select a certain list this way with the list item component. So I know that this is getting a bit complex step by step, but we have to learn how to deal with tree structures. Okay. And of course, you can take a look to the other components here, which are very interesting as well, but we don't have perhaps time for covering all of them in this course. Okay, so now we already know how to get particular, let's say, items from a list, but it could be very interesting if we could combine the items from different branches of the same tree. And there is a very powerful approach for that, which is the relative item component. So if using this component, what we can do is, of course, to connect our data tree with that, and we have to specify the offset, which means the relative position between the items that we want to connect in the tree. So for that, let me explain that with a Grasshopper panel. So first, we have to specify the offset of our branches. So let's imagine that now I want to connect the items, so for instance, the item number 4 with the item number 4 of the next branch and so on. So that would be an offset of 1 for our branches. For that reason, let me write here an offset of 1. And now the offset of the items is going to be 0 because I want to connect the item number 4 with the item number 4 and the number 5 with the number 5 and so on and so forth. So if we try to use this actually, then we can see that nothing is happening. And nothing is happening because our paths, our branches, let's say, are defined by 2 indexes. So if you remember, we can actually overcome this problem by just making right click here and simplifying our tree. So now actually this mask or this offset actually matches the branches for our tree, and you can see how we are getting different items here, and we can test this out by using the line component once again. So if we connect the item A with the item B, now you can see how we're actually connecting items from different branches of our data tree. And again, we can change the offset, or we can even add an offset to our items as well. So let's say, for instance, here 2. And now you can see how we are connecting a certain item with the next branch, but with an offset of 2 items in relation with the original to the original list. And I mean, this goes even farther because now you can see that these lines are interrupted here. But what we could say is, okay, perhaps I want to set this grab path to true or grab items to true. So let me get a Boolean toggle. So if I set this to true, we can see that now when a certain when our paths get to an end, so here they get back to our original branch. So yeah, for instance, 0, 2, 4, 6, and then it could connect with the with the item number 8, but since we don't have any more branches, it would come back to the first branch. And of course, we can do this with the items as well. So the item number 7 would connect with the item number 9, but we don't have sats in this case. So now it would come back to the item number 0. So yeah, as you can see, I mean, this is a very powerful resource, data trees in Grasshopper, but it can get very complex very quickly. So for that reason, we have made this introduction about data trees or tree structures in Grasshopper. And now let's apply our knowledge about data trees to create our space truss structure. So what we are going to do is first to save our Grasshopper definition, and then we are going to save it even with a different name. So let's add _2 right here. And what we are going to do is a bit dramatic because we are going to delete everything that goes after our original truss node. So after these 2 components here. So let's get all these cool item component, and we are going to delete them. We are going to delete this as well, and I think now we are ready to go. So these are and we don't need, and one second, and these are the base nodes that we are going to be using to create our, let's say, space truss structure. But since we are going to be dealing with your structure, the connections are going to work differently than before. So that's the reason why we don't need these components anymore. And finally, let's change something else regarding in comparison to our previous truss definitions. And actually, what we did is that we were moving, let's say, the upper chord. But now what we're going to do is to use the upper chord as a reference plane. So what I mean is that we are going to delete this surface as well, as you can see here, and we are going to use the original surface as reference plane, which means that now we have to move and we don't need that anymore. And which means that we are not going to be moving the original points in the positive vertical direction, but we are going to move them in the negative vertical direction, so that we can vary that height, let's say, without modifying our roof plane. So for that, in order to move them underneath, let's say, what we have to do is to actually, we don't need that anymore, is to reverse the vector that we are plugging into the move component. So in order to reverse a vector, we have to come to our vector category in the components panel and select reverse vector. So now we can connect our original vector here and do this thing here, and now you can see that we have the truss nodes underneath our roof structure. But of course, this shape doesn't make sense anymore because we have to change our graph mapper as well. I'm sorry for that. And now, okay, if we want to make it symmetrical as well, we have to do something like that. Okay, I think this looks nice, and now we are ready to go. So now we basically have our data tree of points of the upper chords and our data tree of points of the lower chords. But if you remember, what we are looking forward is to connect them not vertically but diagonally, which means that we have to, let's say, take these lower points and place them in the middle between our between our upper chords, let's say. So of course there are several possibilities to move these points from this size in the middle, but we're going to learn something new about Grasshopper now. And let me escape our Grasshopper definition once again, and I'm going to draw just 2 points in right now, and I'm using the grid snap to draw them accurately. So let's draw 1 point in the coordinates 1, 1, and the next one in the coordinates, let's say 4, 2. So now what I want to explain is that if we reference these points from Grasshopper with a point parameter, of course, let's get 1 point and let's get the other. What we can do is actually apply mathematical operations to our points. For instance, we can come here to our math category, math tab, and we can select the addition component. So let's try to see what happens, because if we add these 2 points, we can see that the result of adding the point 4, 2 to the point 1, 1 is the point, of course, 5, 3, which means that we are adding the coordinates. And again, we can choose instead the subtraction component. So let's change the order, because if we subtract 1, 1 from 4, 2, the result is going to be 3, 1, and I can see the result for some reason the result should be here, but I can see it perhaps because I have to convert it into a point. Okay, here it is. It was a bit tricky. And now actually we are going to apply this mathematical concept to get the the average between 2 points. So let's say if we are going to add these 2 points and then we divide the result by 2, what we get actually is a point exactly in the middle of our 2 original points. And this is a concept that we are going to use to generate our lower chords. So let's get back to our Grasshopper definition. And of course, since we want to get the points between these, let's say, points from different branches, we have to apply our relative item component once again. So let's get back to our sets category and let's get the relative item component. So this is the tree that we need, and we want the relative item from its branch, which is going to have the same index but with an offset of just 1 path or 1 branch. So let's get this tree here, and we can take a look at the paths, and of course, as we saw before, we need to simplify this tree, so our offset is going to work when we specify the branch offset. So let's get the Grasshopper panel once again, and the offset between branches is going to be 1, and the offset between items, and we have to use a simple bracket for that, is going to be 0. Okay, like that. So now we can see we have these items here and these other items here, and we have to get the average as we did before. So we are going to get the addition component, and you can see what is happening now. But if we get the division component now and we divide this by 2, now, and we are going to hide our original tree to make it more clear. Now you can see how we're actually getting the points that were exactly in the middle between our original branches. Okay, so now let's get our favorite point list component to add a bit of clarity to our Grasshopper definition. So this is our data tree of the points in the upper chords. Sorry. Like that. And now we are going to use the same component to evaluate the points in the lower chords, like that. Okay, so what I want to say is that we have to start as we did with our simple truss, which is basically removing every 2 elements of our nodes, let's say, in order to create our diagonals as we want to. So in order to remove these elements, we are going to get the same component as before, that is the call pattern component. So basically, let's start with the upper chord, and in the upper chord is where the supports are going to be, so we want to keep the first and last item of this list, which means that we need our list here. This is the upper chord, if you remember, and here we have to define our pattern, and for that we need our boolean toggle. We already see that, and since we want to preserve the first item, the first value is going to be true, and the next one is going to be false, like that. So let's get the point list once again, and now you can see how we have removed every 2 items from our upper chords. And let's do the same with the lower chords, but in this case we want to remove the first and end point, because we don't want the supports to be here, but in the upper chords. So for that, let's get this call component once again. Let's copy it. And now what we are going to do, of course, is to remove these wires with pressing and holding the control key. And we are going to change the order. First false and then true. And let's get the point list component to see if we have done it right. And it seems so. Sorry, it doesn't seem so because we didn't connect this guy here. Okay, sorry. Once again. Okay, like that, perfect. So now we have 0 here, 1 here, 2 here, and 3 here. It looks very nice. And now we just have to start connecting the nodes or the points to create our diagonals. So, as we saw before, to connect items from different branches, we have to get our relative item component. And by the way, let me hide this guy. But in this case, we are not going to just connect different branches, but branches of different trees. Because we have this tree in the upper chords, let's say, and the tree of points in the lower chord, which is this guy here. So for that, I mean, this works exactly the same, but we have to get the relative items component instead of the relative item component. So we get this guy here, and first, of course, we have to provide this component with the tree A and then the tree B of the lower chord, and now we just have to, of course, to check that they are simplified. So let's simplify this guy here, and now we have to specify the offset. So first we are going to connect the first item of the first branch with the first item with the first branch of the other tree, and so on and so forth. But if, as you can see, we don't need this last item here, because otherwise we would have an additional line. So what we are going to do in that case is, first of all, to remove this item from our tree structure. And for that, we have to get the call index component as we saw before. So I'm doing this a bit quicker, because we already know how this works. If we want to remove a certain item, we are going to use the call index component. So let me get the points in the upper chord, and these guys here actually, and let's remove the last index, which should be, or the last item, which should have the index -1. And if we write it inside quotation marks, we are going to get it inside of a panel. So like that. Let me see how this works, and you can see that we don't have this last item any longer. So we can plug it as the first tree, and we are going to specify an offset, and in this case this offset is going to be 0, 0, because we are going to be using the same, let's say, branch path of the different trees and the same indexes of our list items. Oh, 1 second, but this should be in simple brackets, so like that. Let me see how this works. Okay, it seems like it's not working because we have to simplify this tree here. We have to take care of that. Simplify, and now we are getting some output here. Okay, it seems like it's working, and let's get the line component to connect those two items. And okay, it seems like we are getting the first diagonals of our truss structure. And now we have to, let's say, get these other diagonals from in this other direction. So for that, what we are going to do, actually, what we want to do is to remove not the last item as we just did, but the first item of our branches of the upper chords. So let's get this, let's get this call index component, and instead of -1, this is going to be 0, because if we connect it with the point list component, you can see that now we have removed the first item. So what we can do, of course, is to copy all these guys, because we are going to be using the same offset. We have just modified the original list or original tree, like that. So this is the first tree, and you can see how we are getting now the diagonals that complete this, let's say, side of our trusses. And now let's go on with the other side, and you can realize that in this case we have to actually apply an offset to our branches, because we're going to be connecting, in this case, the first branch of the lower tree, let's say, with the second branch of the upper tree. So for that, let's copy this guy here. Sorry for that. And the tree structures are, the tree structures that we provided are still right, but we just have to specify here -1. And this is not working because, because we have to specify grab path to true. I hope that is the problem. Because I don't know how to write. That's the problem. Okay, so now you can see how we are generating these diagonals here. And now we need these other diagonals. So let's get this other tree here that works for the other side, and let's copy it, and let's change the offset from 0 to -1, like that. So okay, so now if you take a look, it seems like we have just generated all the diagonals of our trusses. So it seems that we just have to generate our lower chords, because everything else we have already done. So in order to do that, we are going to get back to our original tree structure of our points in the lower chord, which is hopefully this one here. You can see how we are selecting the points, and we just have to connect them with the relative item component, but in this case it's going to be in the same, let's say, tree, so we have to get the relative item component and not relative items. So let's get this guy here, this is our tree, and the offset is going to be 0 for the branches, because the points belong to the same branch or the same chord, and 1 for the items, like that. And let's connect it to our offset parameter, and now it seems like this is working. And let's get the line component to generate our lines or members. And yes, it seems like it's working very, very nice. So let me just hide our point list components, hide hidden, and we can even hide everything that is not a member, actually, like that and like that. And you can see that we already have our space frame parametric structure, and of course we can we can now try modifying our initial parameters, so we can modify the height of our structure, and we can see how the geometry automatically changes. We can even change the number of subdivisions, let's say, as we can do like that with that slider, and we can even go further and play with the actual shape of our truss geometries, like that, with our handles and so on and so forth. And that's not everything, because we can also select our original surface or our original edge curve, let's say, and if we hit F10, we can select our corner points, let's say, and we can see how the geometry adapts to these changes. So I think this was everything. This is our final space truss structure, and I hope you have enjoyed this course. So thank you very much.